Hello and welcome to this video tutorial on posterior probabilities. Posterior probabilities are a really challenging topic to understand, so feel free to stop and rewind at any time and take notes as we go along. We are going to start with an example that I call the treasure hunt. So let's say we have here a set of boxes. As a matter of fact, we have exactly 10 boxes. Some of these boxes have a bone, and some of these boxes have some money. We are interested in the boxes that have some money. Let's see what they have inside then. So if we look inside the boxes, we have three boxes that exactly have money, and we have seven boxes that have some bones. Okay, so now let's go back to our treasure hunt. So here we're again where we cannot see what they have. If we pick one box at random, the question is, what is the probability that this box holds the money? Well, in the fact that, based on the fact that we have 10 boxes and 3 of the 10 boxes have money, we can calculate the probability of holding the money as 30%. On the other hand, since there were 7 bones and there are 10 boxes, the probability that it holds the bones is 70%. That is what we call prior probability. It's the starting probability. Without any extra information, thus the probability that our box holds the money. Now, if I invite Roxy to help me, Roxy also likes to hunt, but he likes better the bones. Anyway, Roxy sometimes barks when there is not in fact a bone in the box, but there is some money. So how do we represent that information? Well, here the first thing that we have is the probability that Roxy will bark given that the box has some money, and that's equal to 40% of the time. So that means that sometimes he mistakenly barks, so that would be like a false positive if we're thinking about a test. On the other hand, he barks 90% of the time given that the box holds a bone. So if I can bring him and ask him to sniff to my box and I can observe his behavior, maybe I can use that information to estimate what is the probability that my box holds the money. That type of probability is going to be called posterior probability because after I invite Roxy to sniff at my box and after I observe its behavior, I can calculate a probability. I have more information and I can use that information to calculate the new probability. So I bring Roxy and he, as soon as he sniffs to my box, starts barking. So now what does that mean? Well, I know that he barks when there is money and I know that he barks when there is a bone. So let's use that information to calculate my posterior probability. So I'll put that information in a table. So first, in the first column, I have the two possible events. I have money or I have a bone. Then I have the prior probabilities, the probabilities that I started with, the 30% and the 70%, and they have to add up to 100% of one. Then I have the barking probability, given that I have money, and that's 40%, and given that I have a bone in the box. Because now we can calculate what is called the joint probability, and it's the probability that he will bark and the money is going to be present in the box, that both things are going to happen simultaneously. And to do that, I multiply the first two columns. So I multiply 0.30 times 0.4 and I get 0.12. And the same thing, 0.7 times 0.9 and I get 0.63. And when I add those two, I get 0.75. 0.75 is the probability that Roxy is going to bark, regardless of what is in the box. So you bring Roxy 75% of the time, he'll bark without taking into account any information about what is in the box. Now I can use that to calculate the posterior probability, and the posterior probability is going to be the ratio of the 0.12 divided by 0.75. You might want to pause here and do the calculations and see if your calculations match my posterior probabilities. Okay, hopefully you did the math right and you found these values, that the posterior probability is 0.16. That means that after Roxy started barking, the probability that I have the money went down from 30% to 16%. On the other hand, the probability that I have a bone in my box went up from 70% to 84%. So now the question is, do I have the bone or do I have the money in my box? Well, given the probabilities, it's very unlikely that I have the money. There is a 84% chance that I have the bone in my box. So let's open the box and see what it holds. Yes, it has the bone. Well, the probability that I had a bone was 84%, which was quite high. So this concludes this short video about how to calculate posterior probabilities. Please feel free to email me or send me questions at my email address at mbrdossy@ubolt.edu.